Okay, in this video we will see how the logic behind the bubble sort works. The logic is very simple. We have this array of values. We are going to start from left to right. It can also be from right to left, but for now we will start from the left side and goes to the right side. The only thing that we need to do here is to compare the two adjacent values and see which one is less, which one is more. If one is less, that should be on the left side. The one that is greater should be on the right side. So now we start from here. We compare 5 and 8. So 5 is less and 8 is greater. So we leave this one, we don't change it. Now we compare 8 and 1. We see that 1 is less and 8 is greater. So we are going to swap these values like this. Next we are going to compare 8 and 6. Again 6 is smaller, so we can swap this one. Then we compare 8 and 9. 8 is less and 9 is more, so we can leave this one like that. Then we compare 9 and 2. So once again we will swap this one. Now after the first pass, we can see that the highest value, the largest number, is on the right side, and then we can start once more. Now again 5 and 1, so we will swap these values. 5 and 6 is okay, 6 and 8 is okay. Then 8 and 2 should be on the left side, and then 8 and 9 are okay. Now we have two values that are sorted on the right side. Then once again we start 1 and 5, no problem. 5 and 6, no problem. 6 and 2, yes, 2 should be shifted here. And then you can see that on this third pass we have the three values sorted. And then we can compare once again. This is okay. And then 5 again is sorted. So this one complete. Now we will again go through the same logic once again, but this time there will be no swapping, because 1 is less, 2 is less, 1 is less than 2, 2 is less than 5, and less than 6, and it goes on like that. So it means this time there was no swapping. So in that case we can finish our sorting algorithm. So this was the basic logic behind bubble sort. Okay, now we will see how to implement the bubble sort. Here is our code. Here we receive the array, we find the length of it, and then we have the one temporary variable that will be used for swapping the values. The first loop starts from I and goes to less than n, means less than the length of the array. And the second loop starts with j is equal to 0 and it goes to n minus 1. The reason for n minus 1 is because here we are trying to compare, this value with this one. Means if this is 0, this is 0 plus 1. And if I am comparing this one and this one, if this is 1, then this is 1 plus 1 means 2. So once it reaches here, this value would be j plus 1, means here we have j plus 1. So we do not need to go to n, in fact up to 5. There is no need to go to the extreme end of the array. When we are on this point, we will be comparing the last element already. So that's why we made this as n minus 1. And again the logic here is the same. If the current value array of j, means this one, is greater than j plus 1, meaning if this one is greater than this one, only then we need to swap them. So then it would be swapped here. That is the only logic. Okay, we will see how we are calling this method from the main method. Here we have our array. We are just displaying that this is the unsorted array, and then display the array, the current array, and then we call the bubble sort to do the sorting. And after that, once again we just display the sorted array. So let us see how this runs. Okay, here you can see this is the unsorted, this is the index in fact, and this is the real array unsorted. We can see here this is the one, and then we have the sorted array. So this is how the bubble sort works.